this video for differentiation, chapter 3. So the topics we're going to talk about is two definition of derivatives and derivative of inverse function and implicit differentiation and derivative using logarithm if it's a complicated function, and also second derivative. Okay, so let's look at the first one. Let f of x is absolute x minus 3 and f of prime of 1 is what, right? So best way to do this, so if you know the function graph by hand, 1, 2, 3 right here. So graph looks like this. That's for the absolute graph. And this one is slope of the graph when x equals 1. So when x equals 1, what is the slope? So that is a slope is a -1, right? So answer is A. Okay. You can make it also piecewise function and then you can take a derivative, or you can just look at it, the graph. Okay. That slope is 1, but they ask you when x is 1, that point, what is the slope? So should it be -1? Next one, number 2. So this one, you have to recognize what is f of x and what is the x value. So let's talk about definition of derivative. Okay. So formal definition of derivative is f of prime of x equals limit h equals 0 f of x plus h minus f of x over h. So by looking at this expression right here, so you have to compare with the definition. So I see it, my f of x then x cubed. Okay, so I see this one cube, so that's like x cubed. That's how I see. And then x plus h is right here, and your x value is a 10. Okay, then that makes sense because 10 cube is right here. Okay, so then I can say, so f of x is x cubed, and the expression itself means f of prime of 10. Okay, so that's how you're gonna recognize now. So when you take a derivative, 3x squared. Now when you substitute 10 into x, 3 times 10 squared, so 300. So answer D. So this problem, I know a lot of people, they try to expand it and try to calculate that one. That's not how you do. This one, you have to recognize that's a definition of derivative. And then find out what is your f of x and what is your x value that time, right? So then you take a derivative and then substitute that x value. Okay. This one is second derivative. So this is second definition of derivative. Second definition of derivative. What is it? In this case, f prime of a equals limit x approaches to a, f of x minus f of a over x minus a. So that is another definition of derivative. It's different from the first one. Okay, so you gotta memorize this. So based on that, you have to recognize what is f of x. So this is f of x. Okay, and right here 2 is f of a. So f of 8 will be 2. That makes sense. If your f of x equals cube root x, then f of 8, cube root of 8 is a 2. So that makes sense. So this entire expression becomes f of prime of 8. Okay, so that's what they ask. So you go ahead, you take a derivative. So this one was x to 1/3 if you change into exponent function. Now when you take a derivative, 1/3, x to 1/3 minus 1 is a negative 2/3. Okay, so f of prime of 8 equals 1/3. Now a to the negative 2/3. So how are you going to compute this? 1/3 times. You can say then basically 1 over a to the 2/3. Okay? Because negative power equals on the denominator. And 1/3 times 1 over, you can say 8 is 2 to the 3rd power. Many ways you can do, but I prefer this way. 1/3 times, so when you multiply exponent, 3 times 2/3 is second power, right? So 1 over 2 square, okay? Because 3 cancel out. So 1 over 3 times 1 over 4 is 1 out of 12. Okay, so B is answer. Now, next one, number 4. So this one also definition, but this is the first one, right? First definition of derivative. So your f of x is cosine x, okay? And they ask you f prime of pi over 3. Because this one is cosine pi over 3, right? Cosine 60 is 1/2. That's the reason. So now you take a derivative. Derivative cosine is negative sine x. If you don't remember, you can watch the other video I uploaded. Derivative of trig function. And then f prime of pi over 3 is negative sine of pi over 3. So sine 60 is root 3 over 2. Okay? So 4 is B. Okay? Now, next one, number 5 here. So use the following table to answer 5 through 10. So this one, checking you understand how to use the table values. Okay? So when you take a derivative, this is the first power law. So 2 times f of x times f prime of x by chain rule. Okay? When you take a derivative. Now you plug in 3. So 2 f of 3 times f prime of 3. F of 3 is right here. When x is 3, f of x is 5. So 2 times 5 times f prime of 3 is a 4. Okay? So 2 times 5 is 10. So 40 will be answer. 5 is D. Okay? Now next one is a quotient rule. So when you take a derivative, denominator square. So I'm going to substitute 3 also. Low D high. Derivative high. Minus high. Derivative low. Okay? And then you use that table value up there. So G of 3 is a 2 times f prime of 3. We already found that that's a 4. Minus f of 3 is a 5. And G prime of 3, right here, 7. Over G of 3 is a 2. 2 square. So 8 minus 35 over 4. So if you compute 8 minus 35, which is negative 27 over 4. Answer A. Okay, that's how you're gonna do. Now number 7. So this one product rule. Okay, and then remember this is a second derivative. So let's take a derivative this one first, twice. So first derivative, f prime of x, I'm gonna substitute 3. Okay, so I have to take another derivative, so I'm gonna just keep it x. f prime of x times g of x plus g prime of x times f of x. That's using product rule. Now second derivative. So you have a product rule and another product rule. Okay, so let me use other color. F double prime of then 3, I'm going to put that in, times g of 3 plus g prime of 3 times f prime of 3. Okay, I use the first one, product rule. Now also second one right here, also if you use the product rule, g double prime of 3 times f of 3 plus f prime of 3 and g prime of 3. Okay, now you have to find out all the values in the table, and then you can now compute. So f double prime of 3 is right here, -3, times g of 3 in the table is a 2, plus g prime of 3 is a 7, f prime of 3 is a 4, plus g double prime of 3 is right here, -2, times f of 3 is a 5, plus f prime of 3, 4, g prime of 3 is 7. Okay, now you just need to multiply it out. So -6 plus 28 plus minus 10 plus 28. So, and if you compute 28, so I got 40. Okay, answer 7, D. Okay, so just delete it one more time and then find the values. So how you gonna do this? So I'm gonna erase this one. If you don't have time to write down, you can always go back this video so you can look at it one more time. Okay, I need some space. Now, so when you take a derivative, you gotta use a chain rule. So g prime of f of x times f prime of x. Okay, make sure you do chain rule. Chain rule is not option, so whenever applicable, you have to do it. Now you plug in 3, so g prime of f of 3 times f prime of 3. Now f of 3 in the table, f of 3 was a 5. So g prime of this one 3 times f prime of 3 is a 4 times 4. What was the g prime of 3? G prime of 3 is a 7. So 7 times 4, so 28 will be your final answer, D. Okay, that's how you're going to use table. Now let's move on here. So, but this is a second derivative, so let's go ahead. Take a derivative once, g prime of f of x times f prime of x, because chain rule. Now, second derivative, so use product rule, right? UV. So derivative of u, so that's the second derivative, times the derivative inside, okay, times f prime of x. So what I did is, up to here is a u prime, and this on v, okay, plus v prime, so f double prime of x times g prime of f of x, okay, so this one is a v prime and this one u, okay, that was a product rule. Now let's plug it in. So h double prime of 3 equals, so you plug in all 3 here, okay, all 3. So what is f of 3 in the table? F of 3 is a 5. So g double prime of 5 times f prime of 3 is a 4. So 4 times 4 plus f double prime of 3 is a -3. So -3 times g prime of f of 3 was a 5. Okay, like that. All right, so let's do a little more. Then g double prime of 5 is 11 here. So that's it. 11 times 4 times 4 plus negative 3 times g prime of 5 negative 4. Okay, so now you just need to use a calculator. 11 times 4 times 4 plus negative times negative will be positive. So 12. So you get 188 is your final answer. 9 is E. Okay, so that's the second derivative. Now this one, logarithm differentiation, number 10. So when you take a derivative of x, f of x, and then f of prime of x, that's how you're going to take a logarithm derivative. Remember that. Now, so then when you plug in 3, h prime of 3 is f of prime of 3 over f of 3. So f of prime of 3, 4 over, over f of 3, 5. So 4 over 5. So that's a 0.8. E will be answer. Okay? So this one, so rule is, let's say you have f of x. When you take a derivative, f of x on the denominator and the f prime of x. That's the rule for the logarithm. Okay? Logarithm function, ln. ln, remember? Next one, number 11. F and f inverse, okay, are both differentiable for all x, and they gave you this one, f of 3 and f of prime of 3, they gave you. Then which of the following must be a line tangent of f inverse, not f of x, f inverse. So to do that, I need to find the slope first. So slope of inverse function is f inverse derivative at 3, right? So then, if you remember the inverse derivative, let's go over function. So inverse derivative of x is 1 over f prime of f inverse of x. Okay, this is a formula you gotta memorize. Okay, so if you follow that rule, so 1 over f of f prime of f inverse of 3. Okay, so what is f inverse of 3? F inverse of 3, we don't have that one yet. So since they don't give you f inverse of 3, so that means we are not looking for that tangent line x equals 3. So basically it's not this one. So then let's find out your slope at 5. Okay, another one. So then you can do 1 over f prime of f inverse of 5. What is f inverse of 5? From here, so you can do f inverse of 5 equals 3. Okay, that's how you're going to find out your inverse value. That means 1 over f prime of 3. Okay, and f prime of 3 is they gave you here, so 1 over 7. So your slope should be 1 over 7. So not this one. So we narrow it down there. Okay, now then what is your y value, right? So when x is a 5, what is your y value? So here's what you can do. Since this point right here, 3,5 is on the original, right? So inverse fund is a 5,3 will be that point is on the inverse. So when you plug in this one, it should work in the inverse, right? So out of this, when you plug in 5 comma 3, which one works? So only this one works, right? When you plug in here 5, then 3, then works. D is not gonna work. So answer is E. Okay. So 3 comma 5 is on the original graph, and then for the inverse one, we're looking for inverse one. The point is should be on the graph like 5.5 comma 3. Okay, and then you can use that point. Okay. Now number 12. Let me erase it here. So this is a second derivative notation. So first derivative dy dx. So what you do is e to the x squared times ln of e times derivative x squared is 2x. Okay. So ln e is 1. You have a 2x e to the then x squared. Now when you take a derivative twice, so this one uv, right? Also product rule. So derivative u is a 2 times e to the x squared plus derivative v is then e to the x squared, same as this one again, right? ln e is 1, so times the 2x times another 2x. So this one is a u prime v, and here is a v prime and u. Okay, so when you simplify, you can take out 2e to the x squared, then 1 plus 2x squared, right? When you factor out. Or you can plug it in 2 there, so same as e, okay? You multiply 2 in here, then it should be e. Now number 13, how you gonna take a derivative of this one? So one thing you should know is inverse sine x derivative, okay? That is 1 over root 1 minus x squared, okay? Other things also you can Google it and then you can memorize it. So make sure you memorize for that unit. Now here, so when you take a derivative, this is a product rule. So u and v. So derivative u is 1 times inverse sine of x plus derivative inverse sine is up there. So 1 over root 1 minus x squared times x. Okay, so which one same as this? So that is a C. Okay, 13 is C. Now here, if ever f of x to the power of g of x or another thing like that, then what you're gonna do is you take ln in the beginning. Okay, so then ln of f of x to the power of g of x, and this one you take in the front. So ln y is g of x times ln of f of x, and then you take a derivative both sides. Okay, that's the way you have to do, memorize. So then let's take ln both sides in the beginning. ln y equals ln of x to the x. Okay, from here when you take a derivative, when you take the ln both sides. Now x you can take in the front. So ln y x times ln x. Now I'm gonna take a derivative. So left hand side 1 over y prime, okay, by implicit. Now this one is u and v. So derivative u 1 times ln x. Now v prime, derivative ln x is 1 over x times u x. So then you get ln x plus 1. Now what is then y prime? Then 1 plus ln x times your y value. Okay, this y value the other side. Y was x to x. Okay, so which one same as that? C. Okay, so the same as C. Now number 15. So implicit this one. So take a derivative. So when you take a derivative as is here, so I'm gonna just put instead of dy dx y prime. That's easier. y prime minus this one is a product rule. Okay, so 2x times y square plus derivative y square is a 2y y prime implicit times x square, and the right hand side any constant will be 0. So I need to isolate y prime. So y prime minus 2xy square minus 2x square y prime equals 0. Okay, when I distribute. So 1 minus 2x square y prime equals 2xy square when I simplify and factor. Now you can divide it. So 2xy square 1 minus 2x square y. Okay, so which one is that? That is A. Okay, 15 is A. So implicit. This one's second derivative. Also, I'm going to do implicit. So first derivative, 2x plus 2y y prime equals 0 when I take a derivative once. Now, so you can isolate y prime here. 2y y prime equals to negative 2x. So y prime is negative x over y. Okay, that's negative x over y. When you reduce by 2. So you can take a derivative one more time from here. So second derivative is, you can do, okay, I look at this on negative x over y. So y square, low d high, minus high derivative low. Okay. Now I need to substitute y prime there. So negative y plus x times y prime was negative x over y square. So let's multiply top and bottom y. Okay. So then y cube on the denominator and negative y square minus just x square. Okay. Or you can take out the negative, then you'll get b. Okay. So 16, second derivative will be b. Now let's talk about number 17. I need some space. So at the moment that rectangle, you have a rectangle here, 8 feet long and 3 feet wide. Its length, so let's say this one length and width. And then what they're saying is TL dt is increasing, so 0.5. I'm going to omit unit for now. And its width is decreasing, so dw over dt, since decreasing, negative 1.5. Area is, what's going to happen is, area is length times width. Okay, so when you take a derivative, dA dt, so this is some product rule. So dl dt times a w plus dw dt times l. Okay, so let's substitute all the values you know. So dl dt is 0.5. W is a 3 right here. And dw dt is negative 1.5. L value is here, 8. Okay, so then you can calculate. So that's 0.5 times 3 is 1.5 minus 1.5 times 8, 12 minus 12. So negative 10.5 square feet per minute. So decreasing. Okay, 17 is A. Now, number 18. A particle is traveling on the curve like this. When the particle is at the point 2, 3 and its x coordinate increasing, so dx dt is a 5. What is dy dt? So dx dt is a 5. question is what is dy dt. So you can take a derivative the given equation here. So 2x times dx dt. Okay, because you're not taking derivative in terms of x, you're taking a derivative in terms of t. Okay, so you have to attach dx dt, and this one is a product rule minus, so dx dt times y plus dy dt times x. Okay, plus 2y dy dt equals 0. Okay. Now let's plug it in all the values you know. So 2 times x value is a 2, dx dt 5 minus dx dt is a 5 times y value is 3 plus dy dt, that's the one you look for, times x value is a 2 plus 2 times y value, so 3, and dy dt equals 0. So only thing you don't know is dy dt. So 20 minus 15 plus 2 dy dt plus 6 dy dt equals 0. So then 20 minus 15 is a 5 minus 2 dy dt plus 6 dy dt equals 0. So 4, collect items, dy dt equals negative 5. And then dy dt is negative 5 over 4, which is negative 1.25. So since it's a negative, so it's decreasing. So you have to say A is decreasing 1.25 units per minute. That should be the answer. Okay, implicit, and then substitute all the values they gave you. Now let's move on here. What is this? This is a second definition of derivative. If you remember what I said beginning. Let me just copy one more time. Limit x approaches to a, f of x minus f of a over x minus a. That's a f of prime of a, second derivative. So we know that ln x is your function. So f of x equals ln x. And then this whole thing is f of prime of a, right? So then f of take a derivative is a 1 over x. And then you substitute, so f of prime of a is substitute a into x, 1 over a. So 19, D is answer. Okay, checking you understand the definition. Okay, last one here. So this one derivative inverse also. I think the best way you do is find the inverse first and then take a derivative from there. That'll be easier. So this one y equals e to the 3x. To find the inverse, you switch x and y. X equals 3, e to the 3y. Now, you can take a derivative as it is, or you can isolate y by taking ln both sides. So ln x equals 3y. So y is 1 over 3 ln x. So now take a derivative. So that is the inverse function. Take a derivative. So f inverse derivative is 1/3 1 over x. Okay, so which is a 1 over 3x. That's your final answer. Okay, so that's it for this video.